Smart light. The word smart seems to be in front of everything now. Smartphone, smart home, smart TV, smart watch, smart switch, and you get the point. Now what do we mean by smart light? The things above all need a central processing unit to help it interpret data. However, light seems to know what to do on its own.
There's a phenomenon we overlook every time we eat out at a restaurant: the physics of refraction. Have you ever looked at a straw inside the water cup? Compared to the straw out of the water, the straw in the water seems to be bent. Let's try some more liquids to see if they are any different.
Let's first see how much water bends the straw. Look at that! The straw looks bent. Maybe it bends differently for the other fluids.
Let's try the vegetable oil. The oil sure seems to bend it more.
How about hand soap? Wow, the straw seems more bent than in oil.
And lastly, rubbing alcohol. Aw, that's not bent very much. Why does this happen?
Well, light is made of small particles called photons. And imagine all these photons are in a race to the finish line. Depending on the conditions of the environment during the race, the photons will change its speed. For example, if a photon slows down, to compensate for the lack of speed, the slower photon takes a shorter path to the finish line to make sure all photons will pass the finish line at the same time. Now the environment are the different mediums the light goes through. Depending on the medium, light's speed changes. To compensate for the slower or faster speeds, light will shift its path to ensure all the light rays will hit the detector at the same moment.
What good is an observation if we can't calculate it? Do not fear, the answers are here. We can calculate the shift in the path of light or the speed of light in the different mediums with Snell's law. Snell's law is n1 sine theta 1 equals n2 sine theta 2. N stands for the speed of light in a vacuum over the speed of light in the medium. Therefore, the bigger the n, the slower the light is.
We know that light travels at around 300 million meters per second in a vacuous space. The air is not much different from space, so during our calculations we can assume the speed of light to be the same.
Let's try finding the degree in which the path was shifted in the cup filled with water. So the light ray of the straw in the water first went from water to glass. The n for water is 1.33, the n for glass is around 1.5. Let's say the angle that the light hit the glass was around 10 degrees. We plug in these numbers in the Snell's law equation, we find that the light ray in the glass is 8.86 degrees from the norm, as expected. The angle of the light ray in glass is less than in water because the light's velocity is faster in water than in glass. So to compensate for the lack of speed, the light takes a shorter path. Then the light travels from glass to air to hit your eye so you can see the straw. N for air is 1, so when we plug the numbers into the formula, we get 13.4 degrees.
Everything around us is governed by the laws of physics, but we live such busy lives that we forget to observe even as common of a thing as light.
So there you go. Now you know more about light, and next time you're sitting at a restaurant, you can calculate the index of refraction of your drink.